everyone. I'm going to start today's lecture. Before I start, does any of you have any questions? Any questions, concerns? Okay, so I'm going to make a few announcements, and I also send announcements through BBLearn. So I had emails from you guys to still being able to submit the extra credit assignments. And if you notice, I so far assigned like more than 50 points extra credits that will be added to 800 at the end, So if you didn't submit those, you have till Friday. At Friday, 5 p.m., I'm going to post the solutions because I want you guys to be as prepared as possible for your final exam. So after that, I won't accept any submissions. But you still, if you didn't submit the extra credit assignments and then you want to do so, you are welcome to do that. Any questions? Yes?
So for the extra credit assignment last week that was on Whiteboard, the quiz, in the grade book it says out of 10. So is it being put in as an assignment out of 10 or the extra credit points?
That is 10 extra points that will be added. So previously, this is another announcement. Previously, I told you that I'm going to add the extra credits, some of them to exam 3, some of them to exam 4. So that is still the same. I'll add all the extra credits together and then add that to your final 800. But if you think about it, it's as if I added those to exam 3 and 4. But I think in this way, it is clear how many credits you have overall, because if I just put a number for exam 3, maybe it would be confusion. How many of those are extra credits? What is my exam? Does that make sense? So I grade all of them individually, put your grade, so you can see your exam 1, 2, 3, 4, and later final exam individually, and then for each extra credit assignments, you see your score for that one too. Does that make sense? And I'm going to grade the extra credit assignments during the dead week next week, so I have more time. And before, if we had like an assignment reading the sections 5.9.4 till 6, before that, as long as you submit the extra credit assignment, as long as you solve the problem, I give you the credit, right or wrong. But for the BBLearn ones, you have the chance to retake it as much as you want to get the full points. For those, you just see your credits, extra credits, right after. So if you get like 7 out of 10, you have the chance to retake it, to increase your grade. Does that make sense? For the BBLearn ones? And after today's lecture, I again posted extra credit assignment in BBLearn because this is much faster. You can just see your grade right away. It's in the format of your tests and final exam. So I decided to do that to save you and me lots of time. Because for the BBLearn assignments that you submitted, some of them, some of you included your notes too, so I had to distinguish which one is actually the answer to homework problem. Some of you included like 6 figures, some of them were like rotated, so I had to like download them, look at them, so that's why it's taking me much longer than I expected to grade those. And the other thing I wanted to tell you guys is that the reason that you cannot see all the extra credit points and all the quizzes, the scores in BBLearn is because of all the extra work that I generated for myself and you to make sure that you get a good grade. If I just, as you see, for your exams, you see your grade the same day or after. Because I have just grade the scantrons, it takes me 2 hours to do so. But for the quizzes, I go through your solutions. I want to see what our students are struggling with to address them, kind of like reading your solutions, the same thing for your homework assignments, give feedback, make sure you're doing well. So that's why they're taking longer. If I just wanted to grade the scantrons for your quizzes, you would see the grades like the day after you take the quiz. So I have some of you emailing me that what is my extra credit assignment grades, I want to know my grades. So as I said, as long as you submitted those, you get the credits for those. But I appreciate you guys' patience because that's what is happening. And also, the study guides that you see that just reading those takes much of your time, right? So you can imagine writing those would take lots of my time too. And also the makeup exams, anything that I'm doing extra, I'm also writing those. So I don't have anything prepared from before. I'm just like writing makeup exams, and then, after each exam, makeup quiz. So all of those things take much of my time. So that's why I'm like slower on grading the extra credit assignments. Does that make sense? Okay, any question about anything that I said so far? The other thing is the evaluations. So the deadline for course evaluations this Friday. I know you guys busy, you have like your final exams, you have like different things to do, but I highly appreciate if you can fill them out. And as I said, pay attention. It's kind of like the multiple choice questions that we have. I know some of you knew the materials, but you didn't like get an A in the exam 4 because you weren't reading the problems well, or just like I was saying, which one is not correct, which one is not combustion reaction, and then you chose combustion reaction. You know what I mean? So pay attention to the question, and the same thing for your course evaluations. It might, start with, for instance, did the instructor care about students? And then it starts with strongly disagree, and then you want to say that you agree or disagree. So pay attention to the order that the questions are structured. So if you want to feel agree or say agree or disagree, you choose the right one. And some of you might have carbon compounds next semester, and I'm going to use your evaluations to design that course and also continue with like Chem 101. So if you like to see your lectures online, please say so. Or if you like the fact that I gave you extra credit assignments, tell me so I do that next semester too. Or anything that you like or dislike about the course, tell me so I can use that for next semester. Otherwise, I just, based on the results that I saw this semester, I just designed the course however I think is the best. But it might not be consistent with what you have in mind, so I need you guys' feedbacks, and those are really valuable to me. Are we clear on that? Any question about student evaluations, like anything that I said? And the other important thing, make sure you know your final exam date and location. The location is the same, and the date is like not the Friday that is coming, the next Friday, I believe 17th. And yes?
How many questions are on the final?
50 questions. And you have 10 chapters. I have like 10 questions from chapter 1 and 2, 10 questions from 3 and 4, 10 questions 5 and 6. Does that make sense? Yes.
2 questions. What time is the final?
10:15 a.m. to 12:15 p.m. It's 2 hours, worth of exam. So come, pay attention. It's in the course schedule that Professor still have in his website. And as I mentioned to you all, I didn't change anything from his course. I'm just like adding extra credits to increase your grades. But in the sense of like quiz date, exam days, final exam hours, everything is the same. And also my office hours, I know that there have been some confusion. I am having Professor Stelk office hours schedule after class 12:30 to 1:30 p.m. But sometimes I add extra office hours because I feel like maybe more office hours are needed. So otherwise I have like his office hours. More questions?
Yeah, I guess 2 more off of that. The first one would be, are you still gonna have extra office hours? And then the second one would be, what is the best way to study for the final, like your study guides or like previous tests, stuff like that?
Okay, so thank you for the questions. First of all, if you want me to, I schedule more office hours, so no problem. How many of you need like more office hours? So what time works for you guys?
I don't care anymore.
Okay, so I'll send some extra office hours. You can also email me too to make sure that I accommodate your time. And what was the other question? Oh, how to study for the final. So as long as you come to the class or watch the lectures for these, I know that some students, probably you guys are the ones that always show up. Some students, they don't come to the class. They don't watch the lectures, and before final, they have like 10 lectures to watch. I wouldn't have the time just one day before the exam to spend like 10 hours watching the lectures, and probably they will pause the videos too, so I know that it's really difficult. So come to the class. That's, I continue coming to the class or watch the lectures. The other thing, study the study guides. Anything that you know for the theories or conceptual problems, I put in the study guides. As long as you know them, you're golden. And your makeup exam, makeup quizzes. I know some professors, they don't post solutions to their exams because they want to reuse them. I don't do that. I think if you take an exam, you should know the solutions. I post all the exam and quiz solutions. Go through them, study them. And if you have any questions, just email me. I have scheduled Zoom meetings for you, tutoring sessions, anything that I can do any time of the day. So don't hesitate to reach out to me at any point about anything, including your quiz and exam solutions. I wrote 2 different versions of makeup exams for exam 1, exam 2, exam 3. After we're done with makeup exams, I'm going to post them with their solutions. Study those too. And all the homework assignments, you might notice from your exam 4 that how similar questions were to your homework assignments. I'm going to use them. So study your homework assignments and self-assessment quizzes from back of your book. Each chapter saw that for chapter 4, 5, and 6 how helpful they were. Study those. And if you do these things that I just said, I think there is no way that you cannot get an A or B in your final. Because I'm just using them to design your test. So, any more questions? Concerns?
What about extra credits going forward? Are you going to do homework problems still?
So I'm going to post in BB Learn. So you can just the structure would be like your exams, and then you have the chance to retake them to increase your grade, and you can see your score immediately. So it would be much more efficient. So yes, I'm going to continue giving you extra credits so you be familiar with the problems and then also increase your grades. Any other questions? Okay, so now I forgot to put the Can anyone tell me what are valence electrons? Exactly. So while I'm doing this, can anyone write electron configuration for carbon? Or explain to me how you write electron configuration for carbon.
Well, you would find carbon and you would figure out that it's 6 electrons.
Uh-huh.
You would do 1s2, because that would be 2 electrons, 2s2, that'd be 4 of them.
Uh-huh.
And then you would do 2p2 to get the rest.
Okay. So is it clear for everyone how we're going to do that? So if you want to write, okay. So in general, I guess let me ask you guys this. How do you write electron configurations? Does anyone, so be showing your hands and just don't be, afraid or embarrassed or whatever. How many of you know how to write electron configurations? Wow, that's a lot. Okay. So maybe because I had so many students, not so many, but some students telling me they don't know how to do so, or maybe there are students that they're not showing up to the class. So anyway, I'm just gonna review this briefly because this is the foundation of chapter 10 that I'm going to teach today. So in general, when I have so first of all, orbit, orbital, Bohr model, and as I said, I'm going to post everything that I write in a PowerPoint, so don't stress out about writing this. You saw from previous 2 sessions, right? You saw the PowerPoint, so don't worry about writing everything. I'm going to post this, so make sure that you know them. And then quantum mechanical model. You see that in some of the tests, not for this course, but you see that match these words with, with the appropriate word. So if I tell you, what model orbit, the concept of orbit corresponds to, which one is that? Exactly. So Bohr was talking about orbits. What about the quantum mechanical model? So as we said, Bohr was saying that if you have like nucleus that has positive charge, we have like orbits around the atom, around the nucleus, right? In each atom, we have orbits, and they are like around nucleus. And it's n equal 1, n equal 2, n equal 3, and so on, right? And this is like a circle around it. So we have like these orbits, like the planetary description, right? But for orbitals, it's like, as we said, it's the probability of where electrons are, right? So we cannot just like visualize it as a straightforward as Bohr model. So do you remember how do we write orbitals? So we had like two things that we would specify each orbital. What are they? A number and a letter, right? So we have like, for instance, 1s, 2s, 2p. And then we said that s orbitals are spherical, p orbitals are dumbbell-like, and all that. And do you remember when we want to fill out the orbitals with electrons, which orbitals do we fill first? The ones at higher energy or lower energy? Anyone? So when we want to fill out orbitals, which ones do we fill out first? Yes? Lower energy, right? Because we have nucleus, and then we have like 1s, 2s, right? Because those are closest to the nucleus, they have the lowest energy. So first, for instance, we write like 1s, right? 1 is principal quantum number or shell or orbits in Bohr model. S is the subshell, right? And then if you remember, when we had like n equals 1, n equals 2, n equals 3 for like different shells. So in n equal 1, how many subshells do I have?
1.
Exactly. So whatever the number of n is, you have that much number of subshells, that many number of subshells. So when n equals 1, you have 1 subshell. So I guess, right, number of subshells. And can anyone tell me what is that subshell? Yes. Yes, exactly. So we call that S. What about n equals 2? How many subshells do we have in n equals 2? Exactly, 2. Whatever the number is, you have that many number of subshells. Can anyone tell me what is that one? What are those? S and P, right? Do you remember? So how many subshells do we have when n equals 3? How many? 3. Whatever the number is, you have that many. And can anyone tell me what are these subshells? Exactly. And then n equals 4. How many subshells? How many? 4. What are those? F, right? Is that clear? Any questions? Yes. So this is the, so you have until even n equals 5, you will be having, so you know, so this is like the maximum number of subshells. So, or you have like only S, P, D, F, because if you go through your periodic table, you know, you have like the maximum number of electrons that you have is like 118, and then the maximum that you have like is, you know, fill out with, let me just like write this. So if you have like, so you have an element that is not discovered yet, but the number of electrons is 118. And then 2 before that, you have like LV, that the number of electrons is 116. So if you write the electronic structure, and I think I have the picture here too. So here, done. Okay. So this is like, these are like the elements that I'm talking about. And it's interesting, in your back of the book, you know, you have like LV, the number of, the name of the elements listed here, but here they didn't write that. And then anyway, so these so here these elements are not known, so your book didn't write the electron configuration. But my point is that, you know, you have maximum till like here, you know, 6D, you know. So what I'm saying is that you won't be having more than that to write. Does that make sense? So for like n equal 5, I think, you know, the rule that we said that now we have 6 subshells or like 7 subshells, you know, that doesn't imply anymore, because you're running out of like the orbitals or like subshells specifically. So the maximum that you have is like F, that corresponds to lanthanides and actinides, or like inner transition metals, because as you can see here is like you have like your transition metals here, and then here you have like the inner transition metals. So the short answer is that it's not applicable. We don't have more than that. And as we mentioned, you know, you can theoretically have like until n equals infinity when an atom loses an electron. It's like basically in n equals infinity, but basic atom lost that electron. So it's the same thing from here. So I think the rule that we just said, that how many, depending on what is the number of n, you have that much number of subshells, is in until n equals 4. Because it's n equals 5, we don't have more letter to specify, because we don't have more than that elements that needs to be filled out. Any more questions? Really good questions. Thank you. Good? Okay. So now, knowing that rule, let me have an page. Okay. So I'm going to ask you to write electron configuration for elements. And when you want to do that, this is the best way. That you say, okay, she said in the class that we fill out the one that is most closest to the nucleus, and that is like n equals 1. So I write 1 S. And she said that whatever the number of n equals 1, we have 1 subshell. So we only have 1 S. And then we have like n equals 2. So I write 2. And she said we have like n equals 2. We have 2 subshells, SP. So I write 2S, 2P. And then we go to n equals 3. And she said when n equals 3, we have 3 subshells, SPD. So I write 3S, 3P, and 3D. So here you have an exception. And if you remember that energy diagram that I showed you, that what is the energy of the orbitals, 4S has lower energy than 3D. Do you remember? That was an exception. And then 4S, the next one, so we already wrote 3D, so I should write 4P. And this is the amount that you should memorize for your exam. So 1S, 2S, 2P, 3S, 3P, 4S, 3D, 4P. And as you saw, I taught you how to write this, so you don't make a mistake or anything. Is that clear? Any question about that? And now you want to, you know, do you remember the superscript here that we write the number? It's the number of electrons. And we said S orbitals are like this. And these are like P orbitals, do you remember? So P subshell, we said it has like 3 orbitals, right? Or I guess I just write here S. And do you remember how many electrons maximum can be here? 2 with opposite spin. What rule was this? Pauli exclusion principle, right? And then it's opposite spins. So here, when I want to fill out electrons for S, so this is 1S, this is 2S, or S in general. So what about P? How many electrons maximum can be in P orbitals? Yes, we have 3 orbitals, it would be 6, right? And do you remember that first I filled them singly and then pair them? Do you remember? 1, 2, 3, 4, 5, 6. Maximum can be 6. And what about D? 1, 2, 3, 4. Do you remember how many orbitals we had in D? 5. How many what is the maximum number of electrons in that? 10. And then when you want to write it, you say 1, 2, 3, 4, 5. You fill them singly first and then pair them up, right? So now that I told you that, and the fact that in orbitals with similar energy, we fill them out singly first and then we pair them up. What rule was that one? Hans rule, remember? So that is definitely going to ask you in your final exam. Hans rule and Pauli exclusion principle. So now that I told you these things, how many electrons are in 2s? Maximum. Anyone? 2, right? Is that clear why? What about P? 6 is the maximum, right? What about 3s? 2, right? So, when you have like S, doesn't matter whether it's 1, 2, 1s, 2s, 3s, it's 2, right? If you have P, the maximum number of electrons would be 6, right? Is there any questions? Whether you know this and it's really boring or it's like confusion? Is this clear? Okay. Okay. 6. What about 4s? What about D? What about P? So now, if I ask you, write the electron configuration for neon, what is the first thing you do? Exactly, you go to your periodic table, read the number above, which is like neon 10, and then you just start counting electrons. If you just write this in your exam, you just count electrons until you have 10 of that, right? So what is electron configuration for neon? Can you just tell me and then I write it? Okay, yeah? Okay. So here you say, okay, 2 and 2 is 4, 4 and 6 are 10. So this is electron configuration for neon. So what about sodium? Can you tell me that one?
1s2, 2s2, 2p6, 3s1.
Is that clear? What about magnesium 12? Yes?
1s2, 2s2, 2p6, 3s1.
And now something that you may notice, if you compare neon, sodium, magnesium, what is, this part is being repeated, right? So to save space and also for other reasons that I'm going to talk about, we can just write sodium as neon 3s1, right? It's the same. This is like neon. Or like for magnesium, we can write neon 3s2. Does that make sense? And now if you do that, and I encourage you, for like your main group elements, like for boron, carbon, nitrogen, oxygen, fluorine, neon, phosphorus, sulfur, chlorine, argon, sodium, magnesium, beryllium, lithium, just go home, write those electronic configurations. And then if you have any questions, ask me, because you're going to see them in your exam. So if you do this, and if you write all the electronic configurations and come to your periodic table, you see that, just if you write the number of valence electrons, that as we said is like the number of electrons in outermost shell. So if you write electronic configuration, the last thing that you write is like for n equals 4. Those would be like, for instance, like your valence electrons. If you just write them and then you come to your periodic table, you see that for like alkali metals group 1A, you see like S1 in all of them. I'm going to highlight them, I guess. Yeah. So hydrogen is an exception, that is not a metal, but it still has like 1s1 configuration. But other than that, here you have like lithium, sodium, potassium, rubidium, cesium, francium, and then they have like S1, all of them. And that is the main reason that they have similar properties, because their electron configuration is the same. The number of valence electrons and their configuration is the same. And if you do for like alkaline earth metals 2A, you see, I guess I do that with blue, 2s2, 3s2, 4s2. So you have like S2. And then if you do that for like, 3A groups, 2s2, 2p1. So you see that, they have like the same electron configuration, but just number of n increases in each of them. And for your noble gases, except helium, that it has like 1s2, except that you have 2s2, 2p6, 3s2, 3p6, so you have s2, p6. And as you can see, you have like 8 electrons in their, these elements, they have 8 electrons in their valence shell. So remember that, because I'm going to go back to this. So now, is it clearer how to write electron configurations? Any questions about that? Because if you know how to do that, next chapter that I'm going to start right now would be much easier. And you'll see. Okay, so now I'm going to start chapter 10. So I guess here, and as I said, I'm going to post all of this in a nice PowerPoint, so you have everything. Don't stress out about, writing them. I post them for you. Okay, so in order to make sure that you get the conceptual problems points, I wrote everything that I'm going to ask you, and I'm going to also wrote them in your study guides. But I wrote them here too, so I'll make sure that you can, answer them. So bonding theories. Do you remember in chapter 1, we were saying that, if we know what elements, or what elements we have, what atoms we have like in each molecule and how they bond together, we know everything about that specific, compound, right? So for instance, if you have CO2, we know that there are carbon and oxygen atoms, and we know if we know how they bond together, we know everything about like that molecule CO2 here. So bonding theories, they are models that predict how atoms bond together to form molecules. And some of you, I remember 2 of you asked me a question before that why do we have H2O? We don't have like H2O2. I mean, we have H2O2, but that's not water. Let me say, for instance, why don't we have like H3O, right? Why is it water like that? So, or why do we write the elements, the compounds, the molecules, or like ionic compounds as what we write them? Why don't we have like NaCl2, Or so kind of like answering deeper questions, or like more fundamental questions, if that makes sense. So these bonding theories, they, help us predict what, how atoms bond together to form molecules. And now, the other question I asked you in your, extra homework assignments in BB Learn 2, that what do bonding theories predict? So they predict how atoms bond together to form compounds. They predict what combinations of atoms form compounds and what combinations do not. For instance, so this is an example. They predict why do we have NaCl but not NaCl2? or why water is H2O, not H3O. Also, they explain shape of the molecules. And as we learned, in the next session, we have like CO2 is like, it has like this structure. It's kind of like it's a straight. But water is like that. H2O is bent. So why do we have like these different structures? Why the shape of the molecules is different? So bonding theories help us to explain that. And when we know the shape of molecules, in turn, they determine many physical and chemical properties of compounds. Is that clear? So can anyone tell me what is bonding theories? Or what are bonding theories? Exactly. So you see models that predict how atoms bond together to form molecules. And then now you know why are they important, or they are really important because they can predict these things that I listed here. Are these clear? Any questions about them? I may also give you true or false. I say that bonding theories help us to determine some physical properties of compounds. True or false? True, right? If I say like all the physical properties, that might not be the most accurate sentence because they predict many of physical and chemical properties, but we should specify which ones. Anyway, so this is this. And now I'm going to go to the second slide. So now there are, as we said, there are like different bonding theories, but in this book we're going to learn about Lewis model. And it was named after the scientist Lewis, G.N. Lewis, who developed it. And now, in Lewis model, we present electrons as dots and draw dot structures or Lewis structures. So remember the definition. I'm going to give you an example momentarily. So I guess, I can just like do that right now. So if, for instance, we want to have like Lewis structure of carbon. So first, you go see like the atomic number of carbon to see how many, electrons it has, and then the same way as Hans rule that you were like filling, the orbital singly first, you do the same here. So you go see at the back of your book that, carbon, so has like 6 electrons overall, and then when you write the electron configuration 1s2 2s2 2p, how many? 2, right? 6 is overall, right? Yeah. 2 here, 2 here. And the thing that is important in Lewis structures and in Lewis model in general, we deal with valence electrons. And as we said, valence electrons are important in participating in reactions, determining properties of matter. So valence electrons are really important. So how many valence electrons are in carbon? How many?
4.
Yes, right? Why? Yes. You see the number here, and then the largest number you have is 2, right? And the number that I mean is, the shell. So the largest number is 2, and then you count all the electrons that are in n equal 2, which are like 2 plus 2. Is that clear? How to count valence electrons? So now when you want to write this, if you wanted to write like the electron configuration for like valence electrons in carbon, you would write like, How would you do that? So you have like 2 here and then 2 here, right? Is that clear? If you have any, I just should like continue with the lecture to make sure that finish the lecture. But if you have question about any of these things, just email me. I explain them in more detail to you. And you are welcome to ask me questions too. So the thing that is important is that carbon has like 4 valence electrons. And when you want to write or draw the Lewis structure or dot structures, you put like 1, 2, 3, 4. That's it. You just do that singly first. Yes?
If you have your valence electrons, which are like on a D or an F, so that they have like 10 or 14 within that, plus the like S and P that are with them, do you write all of those electrons down as the valence?
So your book doesn't talk about them. So your book just talks about main group elements. And I'm not going to ask those, in your exam. But you're welcome to come to my office hour and then we discuss that further. But for the sake of simplicity, your book only talks about, main group elements. And then it, divides those to like covalent molecules or compounds and like ionic compounds. So you're more comfortable with ionic compounds. So we studied those, right? So those ones your book didn't go through them because they were more complicated. Any more questions? Okay. So in Lewis model, we present electrons as dots and draw dot structures or Lewis structures to present molecules. So now dot structures, Lewis structures, which are fairly simple to draw, have tremendous predictive power. So I gave that in your like extra credit assignments too, that like Lewis structures are really complicated. They are like really difficult to draw. True or false? False, right? They're like, you saw that how simple it was. It takes just a few minutes to apply the Lewis model to determine whether a particular set of atoms will form a stable molecule and what that molecule might look like. And again, remember these sentences because you might see them in your exam as true or false. Any question about this so far? Okay. Now, okay. Again, I wrote the sentences right from your book, so you know what type of questions you're going to get in your exam. Although modern chemists also use more advanced bonding theories to better predict molecular properties, the Lewis model remains the simplest method for making quick, everyday predictions about molecules. So Lewis structures, Lewis models, is really simple. It's the simplest model, and then based on that, you can make a quick prediction about the, molecules. Is that clear? I wrote the sentence because, as I said, I'm going to ask this in your exam. So now that I talked about them, it should be like easy to answer the corresponding questions. Okay, now here again are some definitions that we just talked about. I just wrote them again to make sure you have them structured so you can answer the questions. Valence electrons. Valence electrons are those electrons in the outermost principal shell. So if you write it electronic configuration, 1s, 2s, 2p, 3s, 3p, 4s, 3d. So the largest number that you have is n equals 4. And then you count number of electrons in n equals 4. So basically the largest principal number or outermost principal shell, right? And since valence electrons are most important in bonding, the Lewis model focuses on those. So remember, although carbon has 6 electrons total, we focus on 4 valence electrons. We use those to draw Lewis structures. Okay? Any question about that? In the Lewis model, the valence electrons of main group elements are represented as dots surrounding the symbol of the element, and the result is a Lewis structure or dot structure. So if I tell you what is dot structure, we write the symbol of the element and put valence electrons around it. We call that Lewis structure or dot structure. What we did just for carbon. Any question about this before I go to the next slide? Good? Okay. And now, here again, I wrote like things so you know these things, so you don't make a mistake in your exam. Each dot represents a valence electron, right? And we place the dots around the element symbol with a maximum of 2 dots per side. It's kind of like the Pauli exclusion principle that we had, like in each orbital you have maximum 2. Here is the same. Each side we maximum put like 2 dots. And then it says, although the exact location of dots is not critical in this book, in our book, we fill in the dots singly first and then pair them. With the exception of helium, because helium, I'll explain you more next session why is that, because it has like 2 electrons overall. But rather than helium, you kind of do the same thing that you were doing with the Hans rule, that you first, put 1 electron each side, then pair them up, and then you have maximum 2, kind of similar to Pauli exclusion principle. Does that make sense? Okay. Atoms with 8, and this is really important. This is like the foundation of what I'm going to go through in the next class. Atoms with 8 valence electrons, which are particularly stable, are easily identified because they have 8 dots, and we call that an octet. So atoms that have like 8 valence electrons, they are easily identifiable. And they have like 2 dots each side. They have 8 dots overall, and they are like particularly stable, and we call those octet. Any question about that before I go to the next slide? So these are kind of like some definitions, and as I said, including everything here to make sure you see them, you write them, and you know them for your exam. And here we have 3 definitions that I asked you in your extra credit assignments, and I'm going to ask you in the exam too. So then, and I'm going to explain it now. If you have 2 atoms, like lithium and chlorine, or like sodium and chlorine, NaCl, if they transfer electrons, so sodium loses electrons, chlorine gains electrons. If they have transfer of electrons, we will be having ionic bond. We will be having ionic bond. But if the atoms share electrons, like oxygen and hydrogen and oxygen in water, H2O, if they share electrons, we will be having covalent bond. And both of those, I just get so nervous when we have like, 2 minutes left. Anyway, and both of those are chemical bonds. And I asked you, that, in the Lewis model, blank involves the sharing or transfer of electrons to attain stable electron configurations for the bonding atoms. And I gave you ionic bond, covalent bond, chemical bond, all of the above. So, remember, sharing of the electrons is corresponding to covalent bond, and transfer of electrons corresponds to ionic bonds. In either case, the bonding atoms attain stable electron configurations. And in the next class, I'm going to tell you that these elements, they want to reach the noble gas configuration around them. So sodium, if you just remember, it had like 11 electrons. It loses an electron and gets to neon configuration because Noble gases are really stable because they have 8 electrons in their valence shell or octet structure. Any questions? And as I said, make an announcement. You are welcome to take exam 1, 2, 3, 4 this week if you are not happy with your grades. I already graded makeup exams except 3 that I'm continuing grading. So if you want to improve your grades, you're welcome to. But for your final exam, you are welcome to take that earlier, but when the final is done, I'm going to just put your grades and report it. So you don't have any time to make up final exam after it is done. If you think for any reason you might miss it, just take it earlier.
Typing that I do bother you at all? Like,
What's that?
the typing, like, does it bother you at all
What typing?
on the computer?
Oh no, of course not.
Okay, thank you for the help.
What would be, what you said working what would be the answer?
I mean, just email me. Yeah, because I'm not. There are some students that they're just like leaving the country, or like there are like some obligations that they cannot take it. But I just want to emphasize that you cannot take it after, because I had like around 10 students or more emailing me like 1 hour before exam 4 or 1 hour after that they missed it, whether like they mixed the hours or like they had like other issues. So I just want to emphasize you cannot take it after, because I should report the grades and I want to make it available in DBLearn. So if I made a mistake or like something doesn't match what you expect, you have the time to talk with me, and then the Monday I'm gonna report the grades. So there is absolutely no time after Friday. But again, if you think for any reason, if you have like 2 exams on that day or like it doesn't work out for you, you're welcome to email me and I schedule a makeup.
Perfect, thank you.
So we can take it earlier. Yeah, so if we gave you like a heads up this week or something, instead of we take it like Wednesday.
Yes, just email me so I make sure that I set up the time, put it in on my calendar. Yeah, you can.
Awesome. Thank you so much.
Of course. What's up?
And it looks like we have all the problems, right? But I'm not sure if I filled, it looks like we should have got the 100, but I'm not sure if I filled out the bubbles wrong. But I know I like triple checked my bubble filling. So I'm just not.
Can you just send me an email and then I reply with your scantron, making sure that what was the issue?
Okay, that works.
Okay, perfect. Yeah. Final exam? Yes, just email me and I set up a time.
And then just the office hours or something, whatever.
Yes, probably be ran through 220, but I should check the room. To make sure it's on.
Thank you.
Good.